This is the Qidi Plus4, a large fully enclosed CoreXY 3D printer that Qidi sent over in July for testing and I've put many hours on. I'd planned on releasing my review about 2 months ago and was just about done with my initial edit when a safety concern was discovered by a few community members. Because of this, I instead released a PSA addressing the issue in hopes that others would be made aware and that Qidi would address it. Well, I'm pleased to say that shortly after that video was released, I was contacted by Qidi and a plan was put in place to remedy the situation. Since my video, I've had multiple requests for updates on this, and many asking for the review now that those concerns have been resolved. Today, that's exactly what we're gonna do. I'll bring everyone up to speed on the situation, and I'll post my review for those that have been patiently waiting. So, with all that being said, and without further ado, let's get right into today's video.
Thank you to PCBWay for sponsoring today's video. With over a decade of experience, PCBWay provides reliable, high-quality PCB prototyping and fabrication with super fast turnaround times. In addition to PCBs, they offer CNC machining, 3D printing, sheet metal fabrication, and injection molding services. I recently used their SLM printing for a 3D printed toolhead, and the results were fantastic. Whether your project is big or small, PCBWay has you covered with order quantities from 5 to 10,000 boards. Use the link in the description to get a $5 credit towards your first order today.
For anyone that isn't aware of the issue, it all surrounds the SSR for the chamber heater. The one that shipped in the Qidi Plus4 worked fine on 220 volts, but if you're in an area that uses 120 like me in the States, the increased current was causing the coils to get extremely hot. In some of the posts online, the coils were melting and discoloring the electronics around them, with one video showing their SSR smoking. When I checked mine, the same had clearly been happening as I saw swelling and melting. While a temporary patch was put in place in the form of a firmware update that basically just limited the heater's output, that was really just a band-aid. Qidi let me know they were releasing a new replacement SSR that everyone who purchased one of these early units would be receiving that addressed the problem. And they would also be receiving an extra 1 year of warranty on their printer. This sounded like a decent solution, but I expressed an additional concern. While I have no issues swapping out an SSR, I don't feel it's fair to assume that everyone who purchased one of these will feel confident or safe in removing a component that interfaces with AC. I was told that those that fall into this category could contact support to either get a replacement unit or a complete refund. Qidi released a public statement that covers everything I just said, and I'll have it linked in the description. In addition to this, Qidi has stated that prior to a new machine launch, they'll have between 50 and 100 testers spread throughout the globe that can perform testing, which easily would have caught this before the machines made their way into customers' hands. The situation sucks, and it's one that was completely preventable, but I am happy with the resolution. For my machine, I opted to get the new replacement SSR in, so I could take a look at it and go through the process of swapping it out. Before I did, I ran the chamber heater one more time and used my thermal camera to get some footage of the initial SSR. I clocked the coils hitting around 165 Celsius while the chamber warmed to 50 C. I then swapped out the SSR, which involves removing 4 screws from the cover and 3 screws holding it to the back of the printer. Swapping the wires is pretty straightforward, but one very important detail is the order of the wires coming in on the right side is not the same for the new SSR. Once I had it installed, I powered on the printer and once again set the chamber to 50 C. The new coil was much colder at around 50 Celsius, and the only thing I saw get hot was the NTC 5D15 thermistors. At its max, it peaked at around 145 Celsius before dropping down. I did a quick search online and found these are rated up to a working temperature of 200 Celsius, so 145 with the back panel off, causing it to work a bit harder, shouldn't be an issue. That's what I have for updates. With the new SSR in place, I'm using the Qidi Plus4 and have it once again cranking out parts. I changed my first video from public to unlisted since the information in it is no longer up to date, but for anyone interested in seeing it, it will be linked in the description. With that out of the way, we can continue on with my initial review of the Qidi Plus4 before this whole event. Like we typically do, let's first run through the printer specs. The Plus4 is a fully enclosed CoreXY 3D printer with a build volume of 305 by 305 by 280 millimeters. Similar to their previous printers, the internal frame is made of steel and it's surrounded with an external plastic shell. This printer seems to be a departure from Qidi's typical bulky shell and is much slimmer with sharp lines and corners. While the aesthetic might not be for everyone, I really like it. This gives the Plus4 an overall footprint of 505 by 487 by 550 millimeters, not accounting for the additional height you'll need on top for the filament. The transparent plastic door and top window have been replaced with tinted glass. For motion, X, Y, and Z use 10mm steel rods. The AB motors use beefy 9mm belts for moving the toolhead, and the bed rides up and down with two steppers using integrated lead screws. The Plus4 uses a dual-sided powder-coated PEI flexplate system for its bed, and the bed itself is made up of 6mm aluminum that can heat up to 120 Celsius. The toolhead, while sharing some resemblance of the previous two releases, has had some pretty big changes. The front cover rests on two tabs and is just held in place by magnets. Underneath it, you have pretty direct access to all of its internals. This includes a large dual-gear direct drive extruder, an all-metal hotend with hardened tip nozzle for printing abrasives, a 3010 hotend fan, and an inductive probe. Additional things on the toolhead are an inline filament runout sensor, a blade for cutting the filament, and a 50-15 blower laying flat for cooling your prints. While the heatsink of the hotend is very reminiscent of Bambu Labs X and P series, the heating element is fairly different, being an 80 watt and in a different shape. Qidi claims the printer can reach 370 Celsius on one page and 360 on another, but with my unit the screen caps it at 350 and the firmware had it locked at 360. Even at 350, this is at the higher end of any printer I've really reviewed, and it will allow you to print with a very wide range of materials. Much like the last two printers from Qidi that we reviewed, this one also has a chamber heater. This one's design is much better, and it sucks in air from the inside of the printer, passes it through the heater, and cycles it out under the heated bed. This is a 400 watt heater that can be set up to 65 Celsius, but for all my printing, I kept it at 50 to 55 C. For additional cooling, there's an auxiliary fan on the right side of the frame that blows air across the build plate. This has become a bit more of a standard, and while they can be noisy, they've proven themselves to be effective. At the back inside of the printer is a small carbon filter and a nozzle cleaning and purging area. This consists of a brush for scrubbing the nozzle, a chute for purging filament, and a small metal pad to cool the nozzle down and prevent oozing. In my testing, Qidi did a solid job of implementing this, which is a huge relief compared to the weird nozzle routine that the Q1 Pro had. There's also LEDs in the front lip of the machine, and a camera in the top right corner that do a good job of illuminating the print area and letting you wirelessly monitor the print. At the very back top left, where the filament feeds in, there is a buffer system. This, in combination with the toolhead runout sensor, detects both clogs and filament running out. As expected, this printer has automatic bed leveling, and this is done using a combination of the inductive probe in the toolhead and load cells in the bed. This was the case with the Q1 Pro as well, and while I'm not entirely sure what their decision was for going with both load cells and the inductive probe, they seem to have gotten it figured out. Looking at the outside, the right side of the printer is where you'll find your power input, and the backside has an optional Ethernet port. They kept the USB port at the top back right of the printer, which I still think is a silly choice, but other than the initial testing of pre-sliced files, I wirelessly transferred everything to the onboard memory and didn't actually use it. Due to the size and shape of this machine, it's much easier to access, but I'm still not giving them a pass for this. Also on the top of the printer are two handles that sort of retract out of the way, but can be used to move the printer around. The spool holder was removed from behind the printer on the X-Max 3 to sticking out the backside on the Q1 Pro, which was much better, but it was pretty flimsy. The spool holder is now on the back left, but facing forward, and I actually have no complaints about it. Interfacing with the Plus4 is done using a 5-inch screen located at the front top center of the printer. It's bright, fairly responsive, and while it appears to be running its own local firmware and not Klipper screen, I feel that most will be happy with it. On that note, a moment for firmware. The QIDI Plus4 is running Klipper on the back end. Typing the printer's IP address into your web browser gives you full access to the fluid web interface, where you can start and stop jobs, monitor prints, and make tweaks to the config. I also checked, and you can SSH into the printer using the username MKS and password MakerBase in all lowercase at the time of recording this video. I haven't found it necessary to tweak anything on the back end, but I know that at least having the ability to is something that others will be happy about. As far as the actual version of Klipper running, it is a fork. You can see this under the version number in the Fluid dashboard. What all's been changed, I couldn't tell you, but I can't say this surprised me considering it's been this way for the majority of manufacturers running Klipper on off-the-shelf printers. For those interested, I decided to take a quick look under the hood of this printer. Accessing the controller is done by removing all screws in the silver panel and then prying the panel off of its clips. Inside, I found a custom MakerBase board, reminiscent of what QIDI has previously used for their Klipper printers. There's a 32GB eMMC module for the Klipper image and local storage, and 4 onboard drivers. The AB motors are using 2240s, and the Z uses 2209s. There's a 24-volt PSU on the underside of the printer for the heated bed and other electronics. The built-in exhaust fan is beefier than I expected, and there's a small electronics fan mounted onto that back panel. The setup process for the Plus 4 is a pretty simple one. Once out of the box, you're peeling a protective film off the glass door and top panel and attaching the handle to the front door. You then install the front screen, secure the spool with 4 screws, cut a couple of zip ties, and remove the shipping screws from the bed. I would say 15 to 20 minutes is fairly realistic from the unboxing to the first boot. The first time you turn the machine on, after you select the language, it'll tell you to remove the zip ties and bed screws before it attempts to move anything, which is a nice check to prevent accidentally damaging the machine. After that, the printer homes, tells you to attach the spool holder, and will have you load some filament. This is where the guide ends, which I thought was a little strange, but you'll need to go through the initial calibration menu. This can be found under the tool menu. Here you'll find platform calibration, auto bed leveling, and input shaping. According to the quick start guide, you don't need to do the platform calibration, but I missed that. For anyone curious, platform calibration has you take a sheet of paper to find your Z offset. Then it has you jog the tool head with macros to the 4 corners, where you'll adjust bed knobs to essentially align the bed. Since this printer has an inductive probe and load cells, I have no idea why it's such a manual process. Klipper has a built-in tool where you can have the bed sensor bounce on each of the corners as you adjust them to update in real time when it's level with the first corner. Regardless, it seems like it's not needed, so maybe just avoid it unless you're having bed issues. For bed leveling, it'll have you set the bed temperature to a range for the filament you plan on printing with, and once it reaches it, it probes the whole bed. I don't mind that it does this, but I also found it a little weird. Since it's set up to run a variable mesh before each print, the process feels a bit redundant. Once you run input shaping, you're ready to print. It only came with a tiny amount of sample material, so I loaded in a spool of voxel PLA and checked out the pre-sliced files on the included flash drive. There were 5 different models pre-sliced, all under a couple of hours, so I started with the Benchy and worked my way through them. While printing out the fidget toy, I came out to check on the print and noticed that the printer wasn't moving, but the print had stopped after only a handful of layers. What I thought was an error ended up being the runout sensor catching a filament tangle. The print quality of the Benchy was solid, but the other test prints were just okay, not great. I noticed a handful of them had some stringing, and I even saw some under extrusion. Next, I hopped over to the computer to slice up my own files. The Plus 4 is intended to be used with QIDI Slicer QIDI Studio, which is a skinned and slightly modified version of Orca Slicer. I wish they had just released a profile for native Orca Slicer, and imagine there will be one at some point, but for now, my recommendation is to use QIDI Studio. On a positive note, as far as I can tell, they didn't strip features out of the slicer, so if you're familiar with Orca Slicer, you'll feel right at home. Since I had some under extrusion with the test prints, I bumped the PLA temp from 210 to 220 and drop the max flow rate by a few cubic millimeters per second. My initial thinking was that the stock profile was probably just a little too aggressive and we were simply running out of flow. I then sliced up the mini Gargoyle model from 3D Printy to a very large size and sent off the print. This turned out much better, but upon close inspection, I saw one section of the same under extrusion. I'd pretty much ruled out the flow issue with this print, so I wasn't exactly sure what was going on. Next, I moved on to the Sailboat model from 3D Print Bunny. This prints in 3 pieces, consisting of the sail, the base, and a stand. Since I was still dialing things in, I printed each separately. The sail and the base turned out great, but the stand completely stopped extruding when it got to the final small layers. Looking at this and checking my G-code, I started to think that maybe it was heat creep. These smaller top layers were definitely printed slower, and the filament would have had more time in the hot end during these small bits of extrusion and travel moves. So I removed the top and popped open the front door before reprinting the model. It turned out perfect. I've had a handful of others talk to me about heat creep with fully enclosed CoreXY 3D printers, but it's not something that I've had to deal with. So when printing PLA, make sure you at least open the door. I'm hoping Big Tree Tech releases one of their cryo grip plates for this printer, so that I can print at a lower bed temp, which should help prevent heat creep. I imagine someone will end up creating a riser with vents for the top glass for when you're printing with PLA. Wanting to verify that the results with the printer open were repeatable, I printed a very large Crescent moon tea light candle or plant holder and a cyber mask. I had 0 issues with creep, even though the mask had quite a few smaller sections that I don't doubt would have had issues hadn't I opened the printer. I was very happy with the quality of the mask, but could have used supports on the moon for its overhangs. Either way, I was relieved to have consistent extrusion on these longer prints. While there's nothing wrong with printing PLA on this machine, with its high temp hot end, active heater, and enclosed chamber, it's really set up for printing with higher temp materials. The main filament I tend to print with is ABS or ASA, and it just so happened that I needed to do a lot of printing for a couple projects. I recently cut a new panel for my Rat Rig V-Core 4 and decided to print all new parts for it. And I'm building a door on Velta, which took a couple kilograms of filament. For all ABS printing, I used the settings baked into QIDI Studio and only changed part strength parameters. On my first 2 prints, I was particularly observant of the first few layers and noticed right away that the nozzle wasn't quite close enough. This was an easy fix by doing some baby stepping. During my ABS printing, I discovered that if you want consistent results with the first layer, getting the bed and chamber to temperature before starting the print is a must. I know many others that heat soak their printers before printing with ABS or other warp-prone materials, but it's generally not something I've had to do for the parts I'm printing. Because the bed on this is 300 millimeters, giving it a fair bit of room to stretch while warming, and the ABS profile sets the chamber heater to 55 Celsius, I found it to be the best route. With this, I printed trays of ABS parts and they turned out gorgeous. Adhesion was fantastic, which I'm going to attribute to the chamber heater, and the consistency of the extrusion was much better than I expected, considering I did 0 tuning. Bridges were clean, overhangs were smooth, and I was thoroughly impressed. The door on Velta has some large ABS parts, but the QIDI Plus4 handled them like a champ. One thing I was not aware of when I agreed to test out and review this machine was the plans for a multi-material or multicolor add-on. I haven't seen much about it other than a render that looks an awful lot like an AMS. While this printer has the setup for something like this with its filament cutter, buffer, and sensors, until I've used it myself, I can't give any feedback on it and generally have the opinion of buy the product for what it can do today, not based on future promises. While I'm optimistic and hope QIDI can deliver, it's not a feature I'm including in this review. So what are my thoughts on the QIDI Plus4 based on my time with it so far? Well, let's start with the good. I like the build, the setup is simple, and with some slight lessons learned early on, this has proven to be quite a capable machine. The experience feels like a pretty big leap forward from the X Max 3 and even the Q1 Pro. While after opening it up, it can print PLA without an issue, to me it really shines for higher temp materials and abrasives. I have a handful of engineering materials I'm hoping to cover on the channel next year, and the Plus4 is really the only off-the-shelf printer that I have that's even capable of printing with them. Other than the obvious issue with the original SSR, from a hardware standpoint, I've been really happy with this machine, and even the firmware tweaks I'd like to see are relatively minor. This machine clearly draws inspiration from Bamboo Lab, but with their own twist. As for the things I feel could be improved, the firmware, especially on the screen, needs some tweaks. From the method used to manually level the bed to the full mesh, it could be better. The flash drive in the backside of the printer still boggles me, and while it wasn't an issue for me, having the power cable sticking out of the side seems like another odd choice for placement. Also, I'd love to see Qidi work with OrcaSlicer to get the profiles they have in Qidi Studio ported over. If they want to maintain their own fork, so be it, but at least give the rest of us using OrcaSlicer an option to just use one slicer. I still have many more hours of printing to do with this machine, but so far it's been a largely positive experience, and at the $799 price point it's currently going for, I'm happy to have it as an option. And that has been the QIDI Plus4. I hope that you enjoyed this video, and that for anyone that's been wanting an update on the whole situation with the SSR, you're now aware of what's going on. And for everyone that's been waiting on the review that I had put together based off my months of testing leading up to this whole event, you at least now have a better idea of what this machine is capable of. If you have any additional questions, let me know in the comments down below and I will do my best to answer. And as always, if I don't have the answer to your question, I have no problem reaching out directly to Qidi to try to get those answers for you. On that note, don't forget to like and subscribe for more great videos. We make a video just about every single week, so there's always fresh content coming your way. And if you want to support the channel further, there'll be links down below in the description over to our Patreon, where there are some really awesome rewards. Huge thank you to all of our existing Patreon supporters. I appreciate each and every one of you for allowing me to come back every single week and spend more time doing what I love, which is making content for you all to enjoy. With this being the last video of 2024, I hope everybody has a safe and happy New Year's. And as always, this has been Daniel from ModBot, and I look forward to seeing you guys in my next video. Peace, guys!